These are examples from section 5.4 off the notes. So from this problem, we can kind of pattern and see that this is actually a pattern of differences of two cubed numbers. So what we're going to do is figure out what is being cubed. So for the first one, we know that this can be written as z to the third, so that means z is being cubed. And for the second one, we notice that 5 is being cubed. So following the equation here for number 4, this follows the pattern of the a cubed minus b cubed. And again, this is a formula that you need to memorize. So putting it in place and substituting your a's and b's, it would actually look like z minus 5. And again, the first one's squared, so z squared. The next one, you take the z and the 5 and multiply it. Just remember the sign in between is opposite from the first one in the binomial. And then for the last one, we want to go ahead and square the 5. So if we fix this up, it would look something like z minus 5 times z squared plus 5z plus 25. And again, once you fit it into the formula, that is the factored form. Here's another one. And again, if we take a really good look at this one, the first one is actually cubic, and the second term is cubic. So this would actually follow the rule number 4 where it says a cubed plus b cubed. And again, following this formula, we can actually factor it in this fashion. So again, we want to find out what's being cubed. So for the first one, it's actually 2x. And for the second term, it's 4. So again, fitting into the formula, it looks like 2x plus 4 times 2x squared minus 2x times 4 plus 4 squared. So if we go ahead and simplify all of this, it would look like 2x plus 4 times 4x squared minus 8x plus 16. So looking at this one, the first thing we want to do here is see if we can actually take out a greatest common factor. So for this one, it actually has a greatest common factor of y. So we'll go ahead and pull that out. Now looking at this one, hoping that this would actually be cubic. So although we know y to the third is cubic, but 81 is not cubic, nor is 193. In fact, 81 and 93 does not have a common factor. So in this case, this would be your answer. In this case, we notice that there's actually 4 terms. So the checklist that we have on the side pretty much does not apply, except for maybe number 1. But in this case, all 4 of these does not have a greatest common factor. So we're going to go ahead and do something called splitting the middle term. So we're going to go ahead and split the middle, and we're going to see if there's any common factor between these two, and then after that we'll find out to see if these two have anything in common that we can factor out. So for this first part right here, we can actually factor out an x squared. Now the idea is, for this side, we're trying to find the same exact binomial here that's in the purple. So we can get an x minus 2 from this side if we factor out a negative 9. So if we factor out a negative 9, we get x minus 2. Now because these two have an x minus 2, we're just going to write that once, because that's what they have in common. So we're factoring that out, and x squared and negative 9 is what's left over, so we're going to write that as one binomial. You also have to check though to see if that new binomial that you created can be factorable, and in this case this does follow the differences of two squared numbers. So we can go ahead and write it as, let's write down the x minus 2. This would be x plus 3 times x minus 3, and this would be completely factored. Okay, here's another example. So again, I see 4 terms, so there's no greatest common factor. Skipping all the way to number 5, we're going to go ahead and split the middle term. So again, I'm just going to draw a line there, and I'm going to try and find a common factor between these two. So they both have x squared. And again, whatever's left over, what we're trying to do here is try to match this binomial on this side as well. So again, between these two, I do see a 25, but because I want x plus 2 as a binomial, I'm going to factor out a negative 25. They both have x plus 2, so we'll factor those two out. Just write it once. and then what's left over is the x squared and the negative 25. So we'll write that as a binomial. And again, looking at this particular pattern here, this models the differences of two squared numbers, which is the rule number 2 that's in this checklist. So this can be rewritten as x minus 5 times x plus 5. And again, these are all completely factored, so this would be your final answer. So for this one, it does kind of look like it's a binomial squared because this one here, we can write it as 4x squared being squared to get 16x to the fourth. But again, the first thing I'm going to do is go find the greatest common factor. In fact, in this case, both of them has a 16 as factors. So we'll go ahead and factor out the 16 to make this problem a little bit easier. Now again, this pretty much looks like a difference of two squared numbers because if we think about it, x to the fourth is actually being squared by x squared. And as far as negative 16 goes, we can write it as 4 squared. So we can actually rewrite this as the differences of two squared numbers. So this will be 16x squared minus 4 times x squared plus 4. And again, we want to double check to see if any of these binomials are factorable. In this case, this first one is. So we can write it as 16 times x minus 2, x plus 2. And as far as the last one goes, there is no rule to factor something that has a plus sign with two squared numbers. In fact, again, we talked about this in class, but that is, in terms of a solution, is imaginary. So this would be your final answer. Again, following my checklist for this one, I actually would factor out a 3 and y to the third. So each of these have that factor in common. So we have this left over. Now this one looks a little bit tricky, but if you take a look, whenever you have an even power here and it's actually halved or in half for the second term, this possibly can be written as two binomials, which is basically rule number 5. So we can actually, because of the powers here, I'm going to take a guess and see if it actually works as y squared and the other binomial also containing a y squared. So at this point, all we're doing is trying to fill in these last two spots. So again, the rules applies as if it was a regular factoring with quadratics. So again, ask yourself, what multiplies to 6 but adds up to a negative 5? And in this case, it actually works out to be negative 2, negative 3. And again, because these two are not differences of two squared numbers, because 2 is not squared and 3 is not squared, this will be your final answer. So for this one, they're asking us to solve. So again, because it kind of looks like somewhat of a trinomial, most likely this looks like we can try and see if we can factor that guy. So we're going to go ahead and subtract 10x squared from both sides. And we will rearrange it in descending order. And again, notice that the power for this one is a 4 and its half of 4 is 2. So we can actually try and write the binomial as x squared for the first term in each binomial. And then from here again, we're just going to go ahead and see what multiplies to 9 but adds up to a negative 10. And that actually does have factors here. So that can be written as minus 9 minus 1. But then if you look closely, these two, this one here and this one here are actually differences of two squared numbers. So we can actually factor that further. So we get something like x plus 3 times x minus 3, x plus 1 times x minus 1 equals to 0. And again, from here, we're just using the zero property where we are actually looking for a number here and here and here and here where all of them possibly can equal to 0. So if we do that, just like a quadratic, the first one, negative 3 would work, 3, negative 1, and 1. And these would be the 4 answers that you have. And remember, in the beginning of the equation, your degree will indicate how many answers you should have. Now remember, your answers can be either real or imaginary. So here's another example. Again, I'm going to go ahead and set this equal to 0 by subtracting 14x to the third from both sides. writing in descending order, again, what I'm going to do is see if I can first factor it. And in this case, it does have a factor of 2 and x. So we'll be left with x to the fourth minus 7x squared plus 12 equals 0. And again, it looks like we probably can factor out this trinomial. So again, I'm going to write it as, in this case, x squared minus 4 and x squared minus 3. And again, if you go ahead and FOIL this guy here, it does match this trinomial here. But again, double checking the ones on the inside here, x minus 4 is a difference of two squared numbers, so we can write it as 2x times x minus 2 times x plus 2, and then we have x squared minus 3. Now that one definitely is not a differences of two square numbers. So again, we go ahead and solve for 0 for each of the x values. So the first one is 0, the second one has to be 2, the next one has to be negative 2. Now the last one does give out two answers, but if it's hard for you to see, what you can do is again set it equal to 0. So just take that binomial, set it equal to 0, and solve for x. So we'll add 3 to both sides, then square root, so we get plus or minus square root of 3. So the solution to this problem will be 0, 2, negative 2, square root of 3, negative square root of 3. And again, remember, in the beginning of the problem, the degree will tell you exactly how many solutions you should have.